Hey guys, I'm gonna help you out with this Coulomb's Law Lab here. First of all, I have video directions on how to actually do the lab with the program simulation. All right, but when you go to the lab here, when you're doing part two, it's actually asking you to graph. We're going to be using Logger Pro. I'm okay if you use other tools. However, all of my instructions will be for Logger Pro. We'll use it several times throughout the semester, and so I highly recommend you just download it and get used to it. But if you're really against it and want to use Desmos, you have to be able to do these things, okay? And especially being able to label our axes and have our units in equations are going to be really important throughout the whole class. So if you do not know how to do that in Excel or Desmos, go ahead and follow these directions for Logger Pro. Logger Pro is, I think, one of the most logical graphing programs. It's pretty nice. But anyways, so going back to our home page here, as mentioned, I put all the week modules, the newest one on top. So if you scroll all the way down to the bottom, we have physics resources. Here's your download instructions. I just uploaded these new links, so hopefully they are current. Let me know if you have any issues. They should also have Logger Pro on every on-campus computer in the computer labs, learning center, and all of that. Okay. Just a side note, I do have metric conversions, the way that I teach them in case you need some extra practice on that, as well as how to look at your Expert TA in practice mode if you want to go back to those. Okay, so yeah, so I'm going to update this video here. So here is Logger Pro once you get it downloaded. All right, and so note that in here it says use Logger Pro. Be sure to label your axis. You should also have a title to your graph. I'm going to add that in title. I'll update that. Okay, so I'm going to walk you through that first. First of all, if you go to options, graph options, you can get there. Or to me, it's just easier if you double click on that. Okay, so we're going to do force versus distance. And then it shows up as your title. Okay, now in this graph, I said to do distance on the x-axis and force on the y. All right, and so our distance is technically a radius, and that's because that force is actually in 3 dimensions. So it's not just like 1 meter away from you, it's 1 meter in all directions from that charge. All right, so we can label it distance, but I'm actually going to call it R, and our units are in meters. Okay, so half the time you'll see distance in the F is equal to K, Q1, Q2 over R squared. Sometimes you'll see D squared. It's just distance versus radius. It really does mean the same thing. Okay, and Y, we have our force, we have F, and our units are newtons. All right, just use the symbol is the short name. Units, use the symbol, don't spell out newtons. Okay, and the key to this is when we actually do our graphs, it's going to show up as our symbols as opposed to X's and Y's. Okay, so I'm just going to make up some data here just to show you the other tools. All right, so you can see here I've got all these bunches of data points that were just plotted. I like to have the little circles around them. I don't really care if you do or not. However, we need to graph or analyze this, right? So we have our, it says use a best fit curve to show the relationship. All right, and so up here, first of all, this is all bunched down here, so this is not a very good graph. A graph should use about 80 to 90% of your space here. So there's two things you can do. One, this capital A is an auto scale. I personally hate it when it goes right to the edges. So if you click on the outside number and change it, you can kind of manipulate it yourself. I'm going to do, like if I do 2 here, then this is my highest point. So why don't I do 1.5? Okay, so if you click right on the number, you can change that. All right, so now I could see that I'm using a good 80%. I'm a little short here, but that's fine. If you really want to make it better, you can double click on that and change it again. But this is good. Okay, you're going to have more data points and not exactly these same numbers, obviously. Okay, so that was the auto scale. Okay, over here we have different things we can examine. We can get the tangents to line. This is our statistics. Integrals, linear fit. This is clearly not a linear fit, so we're going to go to this guy right here, which is the curve fit. Okay, when I click on this, it gives me all kinds of options. All right, and so if I want to make sure it's not linear, it won't let me hit OK until I hit try fit. But I can see this is an awful relationship. Okay, look at my correlation down here, not good. All right, so let me see if it's a quadratic. We did a lot of quadratics in 121. This does not look quadratic. Okay, this is not great. We're using a simulation, so we should actually have pretty perfect data. All right, and so if we keep going down here, obviously it's getting smaller. Okay, our distance, as our distance is increasing, our force is decreasing. So let's see if it is an inverse. Tri-fit, it's getting closer, but still not great. So let's try an inverse square, and bam, we have a perfect fit here. Okay, this is an inverse square relationship because our F is proportional to 1 over r squared. If you read or saw the notes, you should see that. That shouldn't be really a guessing game for you. But that tri-fit works, and I hit OK, and there it is. And I can move this guy around. And so now I can see my F is equal to A over R squared. Okay, A is just a placeholder for, in this case, would be the equivalent to K times Q times Q. We're more worried about the relationship. Okay, so when it's asking here, what is the relationship between distance and force of the charges? Obviously, it's an inverse square law. All right, and so if you want to write a statement of proportionality, that's where this kind of equation comes in. You can write it as F is proportional to 1 over r squared, or F is equal to A over r squared, where again, A is equal to the KQQ. Okay. And that's how we do this. When you're inserting this, I only really need the graph because we already have your data point. So you can click on the data or click on the graph. Just click on the graph. And if you copy that, you can go back to here and obviously paste it in there or take a screenshot, either way. Okay, and then you can auto scale it or size it however you want. All right. Oh, that did not work. Okay, just make sure I can see this whole thing. So when I'm grading this on that rubric, I'm looking for your axes with the name and the unit. I'm looking for a title, and I'm looking for this curve fit, in this case, that inverse square. All right, once again, if you are really good at Excel graphing or Desmos graphing and you are able to do all of those things with it, feel free to use that. But if you're not able to change those axes, then go ahead and download Logger Pro.